Okay, sorry for this interruption. I think I had some problems with this streaming. Let's wait until everyone joins again. Seems that everyone is joining us. Okay, so we can continue. Yes, let's move on. Yeah, again, just if you want to make your class to be clonable, you need to point that it is clonable by adding the interface of by any interface called clonable to your class, assign it to your class. And the second point is to throw the exception clone not supported, and after that you will be able to clone the object. Right, let's this is it for clone, and yes, let's move on. I think we can use this the same class. Just one thing, as you remember, this is the keyword which points us to the current object we are currently in, and again this can be used as the simple variable as well. So if let's just call another method. Let's just create another method. Private void. Just let's call it as this. Here we can add. Okay, let's for example change it to. For example, yeah. Since I see there's the question. This question from Zana. Yeah, for Zana maybe you have not defined these variables. Could you just show the? Can you just show the screen share where you declared A and B? Please. Yeah, that's the question for Zana. Okay. By the way, let's move on until Zana sends the screenshot where A and B are defined. And again, here you can see that object is named with lowercase, so it's not the same as object with O as uppercase, which is considered as object as the class, which is, as you know, it's the parent class of all the classes. So in this case, it's just a variable. Okay, there's the question to Zana. And yes, Zana, I see you have okay. Sorry. Let me check. Okay. Yes. Okay. And where's the red? Where's the problem you have? Where's the place you have the problem? Oh, yeah, I see. Yeah, then just noticed you have yeah, that's the answer for Zani. You have defined here. You have defined variable instance 2 as object, not as test reference. So you have to replace object, which is the class you pointed here to, you written here to test ref. So in this case, yeah, that's you have the problem because yeah, maybe let's move back a bit, because originally object don't have any, actually don't have any global attributes to be used, and yeah, in this case it doesn't have such attribute A, and that's the error, and that's the reason of the error. And mostly we use object to the main use for object class is to transport the instances in case we don't have, if we don't know the exact type of the reference which is assigned to the variable. We need to transport from one place to another. In this case, object type is very useful to actually, again, to transport, to pass the variables from one place to another. If we have a huge framework, like for example, if it's web development, we have so many views, and we just need to pass kind of context nodes from one view to another, and this is in this case this is a huge framework which has the let's call it like generic code, and you cannot transport any specific class there. That's why it is most likely that you need to use such more general classes like object. Right? But yeah, most likely we will talk about it later as well. So yes, as we can see here, we have test ref, and even in this case we can use this option, right? And just yeah, since we just talked about object as the class, as the type to be used here, we can use it here as well, and so let's so here we define a new variable, and what we can see here, we can do the casting, and you see there are no syntax error, and I think we haven't discussed it during the Friday session or Saturday session. I think it is most likely then we'll talk about yes, we'll talk about it on Wednesday, but in this case there are, yeah, we already talked about typecasting. So this is, as you maybe you have noticed that this is the typecasting, and there are two types of castings, upcasting and downcasting. We'll talk about it, as I said, on Wednesday. But in this case, you can see that we can cast the generic object, the object with the generic type. In this case, it's object 2, more specific, which is test ref. Since, as you already know, all the objects are all the classes are inherited from object, and in this case we can just do it this way. And here you can see, yes, no use token. That's fine. Maybe let's choose. Okay, touch it now. I'll talk about it later. But okay, as we can see here, we used object as the parameter. Yes, and with the type object as the class. And as you can see here, we casted it to more specific variable to instance. If we don't have it, it will show us that the types are different, and we cannot proceed this way. But if we point that let's cast it to the type of test ref, it will work. It will work, and let's just let's just hold on. What's this? So instance. Let's just for example print it system. And, right, then let's okay, we can even use the constructor. So now we can see that there is a constructor, and we can even call the method pass this directly from the constructor. And what we see here, first of all, again related to the casting, here we defined that we want to import the variable with the reference type to object, but in this case we actually, just basically what do I want to say here, that this can be used, it can be used, and it actually is the separate object. It is the object, so we can deal with this as the variable. So this one is also the variable, which can be passed to any other method, to any other variable, and so on and so on. Even we can create okay, let's but yes, we can, for example, let's create I have no imagination to find a new name for the variable. So in this case, you can see that we can pass this as the variable. So this is just the same variable as any other object with reference, which in this case is test ref, right? So yeah, just a point for you, so you can understand. So at the moment we don't, okay, so we'll leave it as is. It's not really important here. So yes, and okay, let's for example comment this section out, and this one as well. We don't really need it at the moment. So let's write the test, and here you can see the constructor's code. It calls this method, which passes. It calls pass this method, which passes the parameter this, which is actually considered as the variable in this case. So, and here it is used. We do the casting, and we print out the value of the attribute where we assigned here, right? So yeah, basically that was, I wanted to show that again. This is variable, the same as any other object, and it can be used in the same way as any other object is used. Right, let's move on. Let's move on, and yes, just when we are talking about so-called top-down design, maybe have a short reminder about it. Top-down design. So again, this the approach of object-oriented programming, which is considered as the best practice, and in the way you should create the design of the classes, of the hierarchy of the classes you are creating. You must consider that uh, you must use top-down design, right? Because that's the way object-oriented programming should work. And yeah, again, the idea is that you go from more general to more detailed. Right? In this case, again, have clock. There are three types of clock. Just a simple clock with hours and minutes and seconds. Then there's the date. Here's the seconds, so there should be no difference between these seconds and these seconds. Actually, they are not linked with each other, but there should be seconds as well. So yeah, there's the date with month and day, and there's the count over seconds and microseconds, and you can see that these three things are not connected with each other. That's the key point, that you don't need to connect the subclasses. Let's just call them directly the subclasses with each other. That's the very important point. You need to understand when you create the design of the hierarchy of the classes. Right, then let me show you the example where there's the difference between structured code, so-called structured code, and unstructured code. And this is actually a short introduction to the best practices of object-oriented programming. So let's proceed. So structured code. Okay. Yeah, we can just have simple method here. So imagine we just have the method, then there are several attributes here. Let's see, a moment. So imagine we have two variables defined locally. Count number and count balance. Then we just have count balance equals account balance, for example, plus 10 plus 100. Yeah, then for example, if you want to print it, sorry, count number plus count here's the question. Yes, yeah, that's the answer for you. I think that most likely that your package is starting with the name of your package is starting with yeah, that's not a huge crime, but yeah, as I mentioned on Saturday, this is not the best way the package are named. Yeah, let's just solve this issue. That's yeah, just for you to point that this is the best practice for naming packages. Yeah, the packages need to be named in starting with lowercase letter and not with uppercase. So in this case, these two packages are named without following naming conventions for the packages, so these are not correct. But this one is correct since it is named with uppercase, starting with lowercase. Maybe yeah, we can we can just solve this. Can just solve this by typing using the camel case. Yeah, since it's just for testing purposes, we can rename the packages, but on your practice, I'm not suggesting changing the packages because that can cause you some problems. But yeah, that's the good point, Win. That's the good point. The packages need to be started with lowercase and classes with uppercase. Yeah, that's the good point. That's a very good point. Okay, let's move on. Just a small example. Let's continue here. Just set the count balance. Then we have count balance. Then let's just change this count balance. Number count balance. Then let's change it again with. So again, sorry, what have I done here? Yeah, this way. So as you can see, this is messy code, unstructured code. Why? Because we just, example here, we just do the same thing for 3 times, and it is called unstructured code, because that one is not good, because again we do the same thing for 3 times, which is not good. And yeah, this is unstructured code. Don't do this in your practice. And let's create structured code. Structured code. We don't actually need it here, so just copy the code from them. So how to solve it? First of all, let's create. Okay, we don't need any object here. That's why we can use static one. For example, let's create the void show data. Show data. Sorry. Typo. We can move this parameters globally. So as we can see here, there's the problem. Why? Because again, yeah, we discussed it already, but let me explain again that the problem is that we are in the static method, but we want, and that's why we cannot access the attributes which are not static. Again, as you remember, we can access only the static attributes from the static methods. That's why we need to add static here, and error will be solved, but the approach I like more to use is when we actually point the class we are from, so we can distinguish the local variables and global variables. It's in Eclipse and in most other IDEs you can see that there's the font changed. No, not changed, but different font used for static global static variables. And in this case, we can actually distinguish the variables defined declared locally and globally, just by seeing that these are in italic, and yeah, maybe that's a bit different font used here. But again, just I like this approach. If you like just by distinguishing them by seeing that these one are in italic, arcs are not in italic, so it's fine as well. I like using the prefix which points us to the class this variable belong to. That's my approach. I just like it more. In other programming languages, this can be more serious because not all the environments are so friendly as here when we can distinguish them. But again, yeah, that's how do you want to, how do you like more? You can use the approach you like more, right? Okay, then here we can just pass the code here, and what we see here we don't need it anymore. Just delete all these calls. Maybe just to distinguish them. Let's call the method. Let's call the method show data from here. Show data, and just repeat it from here. Just repeat it from here, and what you can see that it is basically the same code, but we don't repeat the same code for several times. We just call the method. So we moved the code outside, and here we just do the method code. So this is the difference between structured code and unstructured code. That's code here. Here we can see. Here we can see there's the output 20, 200, 20, 150, 20, 140, And yeah, the unstructured code, let's code. So I remember 200, 150, and 240. And unstructured code has the same results, but we have such a bit messy thing here that basically we repeat the same code for several times, which is not really good. In theory, here we also have a bit of repeating, but yeah, it's twice. It's um, it's twice as short as the one from the unstructured code. And yeah, this is the good approach if you use it this way. Right. Yes. Okay. Let's move on. Let's move on. Let's move on. Yeah. As you remember, we had the topic encapsulation. So as you remember, encapsulation is the approach where we want to hide the variables, declaring them private, protected, or public. So in public case, we don't hide the attributes. So I think one moment. I think we can even use the same. Let me structure code. So we have a good example here. And again, maybe just let's create a new class. So let's talk about encapsulation. And for this purpose, we'll create a new class. A new class account. New class account, and let's declare two instance variables here: account number and account balance again. So in this case, these will be defined as the instance variables, non-static. Then yeah. Then let's create the method. Void show data. Let's just do it this way. And here we I think we just can use a bit remember tired of typing all these system print so we can just copy it from there. Here we can see just checks the class which is in the same package. We don't need it, so in this case it will search for the class which is here. I mean this one. We don't actually need this, so we use this one. So as we are inside the instance method, we can use, and it's recommended to use this modifier. So again, as you can see, there's different there's talking about the font and the color of the variables. You can see that the global variables are not in italic, but they are in blue. So again, this is also the way you can distinguish global variables, which are defined as the instance variables. But yeah, again, for me, it's more easier to understand by using this and to not try to remember the case these variables are, which font in which font these variables are written. Even especially if you are if you are working with lots of different programming languages. So in this case, you have a bit different style of coding, a bit different style of font style, colors of the fonts used. So in this case, it can be a bit confused for those who need to switch between the languages, and you cannot remember all the fonts used in different languages. Right, let's move on and just let's, for example, have new void public void deposit, which will pass the deposit. So in case, for example, if we have a negative deposit, then let's just print out that there's an error here. Otherwise, if everything is fine, then let's just use CS plus equals, so we can add the variable provided here. And what we can see here, we can see that there is encapsulation used. There is encapsulation used here. Why it is encapsulation? In the way that the variables are defined as private, so we cannot access them directly from outside the class. And again, why do we need it? Just basically for those who use this class. For those who use this class, they cannot access these variables directly. And why it is needed, as I described on Saturday, and I'll repeat, we need it because for some cases we need, for example, do the check on the input. As in this case, you can see that, for example, we want to put some money on the deposit. In this case, deposit is considered as the variable a, which is called from somewhere. Imagine outside the class. Let's consider this and imagine that this class is used outside this class. So okay, you can see there's the public void. So it means that we can access this. We can call this method from outside the class. From outside the class, then we pass the parameter a, and here as you can see, it has the internal check. If the variable is provided, if there is correct variable provided, the variable with correct value, the value which can be used here, and otherwise if it cannot be used, so we can print the error and do nothing. Do not allow the global attribute to be changed. So this is the case. This is as an example for the case when it is very important. It's very important also in lots of frameworks. There are some restrictions to different users, and for example, in this case, it is also possible that there's a check on the username. We don't here, but for example, if there's also like a username provided here, string username, just if we, for example, want to just another else if statement. Else if, for example, we do not want to allow. Let's call it show like Maris or Davis to to um, yeah, sorry, yeah, that's typical error. So yeah, consider the difference between double equal sign and just a single one. So system out, let's for example print it here. Sorry, example print it here. Maris is Maris just yeah. Maris cannot change the account balance. And he is blocked. And that's another point why the encapsulation can be used. Right? For example, if we want to restrict the ability to change the variable, the attributes of the class, the attributes of the object in particular, so we need to do the encapsulation. We need to do the encapsulation first of all, again, to check if the input is correct. Imagine that there are users and you have like any field you can just type something, and if you type something wrong, then actually the code need to check if the input is correct and do not allow you to do the changes. Right. Okay, I think this is pretty clear for us. We can have a break now, and after that we'll have the last things to discuss today. Okay. Okay, yeah, welcome back, and now we can discuss the first task of the practical assignment for activity 4. So you can go to the package activity 04 and open the first file, the first class road, and we can just do all the steps here. Not complicated, just can do one by one. So first of all, yeah, we have class road, which has three global attributes. All of them are instance attributes. Again, instance attributes belong to the object, which is referred to will belong to the object which is referred to the class road. In this case, yeah, two of them are strings. First one is starting point, considered as a starting point. The second one, 2, is considered as endpoint, and the distance one is the measure of distance in kilometers. So first of all, it is asked to generate the constructor using fields and create constructor which sets from, to, and distance only to a newly created object. Let's do it. Again, we can, another tricky point is, not tricky, but point that we can generate constructor from here. There are two types of constructor. Okay, we can even check how we are asked to generate constructor using fields. So we can select them all. Generate constructor comments if needed. And as we can see, it created us constructor there, but we actually don't really want it. Want it to be created here, and as we can see, it created us the constructor. That was Control S, but it's tricky. But okay. So as we can see, it generated as the constructor. It also called the superclass, but in our case it is not really needed because we don't actually have the superclass, which is different from object. There is no need to call the constructor of object class. The class which is object, right? Not object, but the class which is called object. Again, which is the parent class of all the classes in Java. So in this case, you can see that the constructor is generated. Let's check. So yeah, as we've seen that there's a source, and there can be two types of constructors generated. First one using field, the second one using superclass. As we can see there, we have the only superclass, which is object. And there's basically nothing inside. So as we can see, there's nothing special here. If we generate from the superclass, in case you have the superclass which is different from object, I mean class object, that will have a big different result. But yeah, okay, never mind at the moment. So yeah, as the task, we generated constructor using fields and yeah, create constructor which sets to, from, to, and distance for the global variables. Yeah, it is done here, as you can see. It is done here. Let's move on. Second point, we just need to create a constructor without any parameters, which sets empty values. As we can see, we cannot create two constructors with the same pattern of variables. So even in case we delete one of them, it will be fine. But In our case, it is asked to create the constructor with no parameters passed, and sorry, and all of them. This says that all of them needs to be initialized. As you can see that from is from is a string, so we cannot pass integer. We need to pass just initial value here. As you can see, by default, as you already know, by default, all these values will be initial. As it is asked here, we can do it in this way, so it's the same way if we just skip this, right? By default, all these values will be the same. Yes, yeah. Just to get the constructor, you need to press yeah. That's the answer to Helena. You need to press on the class, right click on the class, then go to source, right? Go to source, and here you can see you can generate constructor using fields. And again, go here and you can select all the fields, which will be. It will create the constructor where the fields are maintained using the parameters passed to the constructor. Right? So we completed the steps task. In the second step, let's move on with the third step. It is asked again generate getters and setters to get the fields. As you remember, it is done in the same way, in a similar way as we already done it in activity 3. Here, right click on the roads class, then go to source, and here you see the option generate getters and setters. Right? Since it is asked for all the fields, we just select all the fields. Right? For distance from and to, we can again generate comments if needed. In our case, we don't really need them. And again, it generates everything on the top. Which we don't actually need. So let's just move it down. And yeah, again, here we can see that getter methods and setter methods are created. Right, maybe I will do small adjustment here. I will add, because I like it more. I like it more if we use this keyword, and that's just a small thing which does not affect the code in general. Right, let's do the last step. As you can see, let's generate the method to string. It is done in the same way, practically in the same way. Again, go to source, then select generate to string. And let's read what is it written here. To implement this method that returns string in from. Okay, let's point to okay. Yeah, here it is. Right. and yeah, we don't need this one. Yeah, that's dash. Again, sorry. Just from to okay, yeah. Yeah. So here we need to implement it this way from then let's write 2 from A to from to 2, right? Then okay, we need a command, then we need distance. We just need to skip the distance. Skip the distance, then we need to pass the kilometers here. Right, I think this is pretty it what is asked here. And again, what happened here, you can see that the method is override because toString is inherited from object class, right? As we discussed it during the last session. Here it is. That's the default method which comes from object class. And yeah, it's recommended to override to have the right output. So let's, for example, test this class. We can just have not here, but let's have it at the end. Our favorite public static void main string args as usual, right? So now we'll be able to execute this class, and let's create a class route. Let's create the object route. Use my route plus your route. Then we can pass the constructor. As you remember, it's from to, and yeah, there's already a hint that we can put from sample Riga, like using Latvian letters from Riga, then to Liepaja. Just add distance. Maybe let's search for the actual distance from Riga to Liepaja. But the distance is like 218 kilometers. And then now we have the object created. So now we can call again print ln and write my route to string. And let's close it. And let's run it. Yeah, as we can see, we need to add a bit more spaces. So let's do it. Let's recheck it again. Let's see from Riga, and we don't need comma here because it doesn't make sense. Okay, we can leave these commas here. And yeah, you can just see that the output is the right one. And in the same way, we can do it by not using different constructor. Let's, for example, comment out this one. We can have just the simple empty constructor here, and then let's call my road. Then okay, as you can see, okay, in this case we can access the private attributes because we are in the same class. We are in the road class. But let's imagine we are outside the class, so we cannot. Let's imagine we cannot access them. So let's set distance. So distance 218 kilometers. Then let's set from Riga again. From Riga, my road set to Liepāja again. And it will provide the same result. So two different approaches can be used here. Right. Okay. So this will be the home task for this Friday will be to not for Friday, but be for Saturday. Until the end of the Saturday, please just finish activity 4 till the end. So there are two more tasks. There are two more tasks to be finished, to be done. And yes, you're also welcome to do the extra activity from the fourth one. Right. Just 1 second. Okay, let's move on. Yeah, one more thing to discuss today. As you remember from last session, let's go back a bit to last session. We had so-called topics like coupling and cohesion. Then let's maybe talk go a bit deeper with these two terms, because they are quite important to understand the general concept, what we want to achieve using object-oriented programming, and especially in Java. So basically what we want to achieve, again, as I said last time, a good we want to achieve so-called loose coupling, which means that there is a small coupling, and we want to achieve a high cohesion, which means that, yeah, again, wow, we need to use coupling, and we need to achieve height cohesion. So let's show you. Let me show you some examples here. So this is so-called Tite Coupling, which is bad programming design, which is not a good example. So let's imagine we have two classes. Just have class B, for example. Class B here. Let's imagine it has the public static void again. Public static void. Yes, main again with strings passed as the arguments. Then let's imagine we create the instance of this class, the object with the reference of this class. Just create object, new Tite Coupling, and yeah, this way. And here let's define global variable public string name. Then let's, as you can see, it's defined as public, not actually the way we usually do it. Public, then string get name. That's the method to return the name, and what you can see here. Oh yeah, okay. Not yet, but yes. Get name if this name not equal no, then return name. Otherwise return not initialized. Okay, again, the equivalent approach would be if we don't use else statement because actually it will go here anyway. If we return something, it stops the execution of the method. In this case, it will not go here if something is returned before. Yes, I think it makes sense. Then okay, imagine we have the setter method. In this case, let's write it. Set name string s string, yeah, it's fine. Then if s equals no, then system out print ln. We don't need to because you can't initialize them. Is name to null, right? So yeah, basically the idea is that we do not allow the name to be initialized to null. And yes, imagine we want to initialize it from class B. Maybe yes again. It's good point that the classes should start with uppercase. Then let's go with B. Then we have initialized the object of Tite Coupling, and for example we can access the variable name directly, and we just want to assign it to null, right? And s again object name. As you can see, the variable here should be okay. We can but anyway, we will not do the output. Yeah, sorry. So yeah, no, it should. Okay, doesn't matter. We will not call this class because it's not the public one. So, but I think you should understand it this way. So here we access the attribute directly, so it does not have any checks on the value of the value we want to set to the attributes of the object, and that's why it is not a good way, because again the attribute is defined as the public, and we can do whatever we want with it. We can assign null as the value of this variable, which is not good, and we don't want to initialize it with null, and yeah, that's the way we skip the setter method. We skip the check which is here, but otherwise let's just add another this name was s. Yeah, otherwise if we define this as the private one, so yeah, again this is called Tite Coupling, and this approach is not good because again we can access the variable which needs to have some checks before we initialize it. So this is not a good example, but yes, we can create basically the same. We can create the same class, not the same, but the similar class with so-called rules coupling. Example. Okay, don't need it still. I think we can manage to go without the initialization. Then let's just we'll have practically the same code, but with some small changes. So yeah, those coupling. Then let's just press them. Sorry, just change the name. Let's complete coupling and change it here as well. Alright. Change it here as well. Yes. Let's call for example type C, class C. It doesn't really matter. So, and if we change the access modifier to private here, then we will not be able to do such thing like direct access to the global variable of the object. So here it is not possible anymore. And now we have to call the method setName. Then, for example, on the provide null here, it's fine from the syntax point of view. It's fine from the syntax point of view, but again, yeah, here it is not also possible to read the value. So for this purpose, we use getName, and it will return as the name which belongs to this object. And in addition to the output, we will have basically we have the output which will describe as what's the problem, right? Okay, maybe let's do have maybe okay, maybe let's maybe show it differently. So if I move the code here, so basically what I want to execute this class. That's why I'm just actually changing the reallocate the code. So it should be fine. Let's run the code. As you can see, we have the right description. What's the problem? Basically, if we try to initialize the name was no, it returns us that we can do it this way. So this is called loose coupling, which is a good approach. And maybe again, let's go back to that Tite coupling. Yeah, sorry, just did it initially wrong. Initially I did it wrong. So need to reallocate the code so we can execute it. Right, and here if we define this as public, so we don't, for example, we don't use set method here, and sorry, name. Yeah. And here basically we don't have any description. It just tells us that name is null. It is not really correct because we don't have the explanation why what's going on here. And this is called Tite coupling, and this is called loose coupling, which is a good approach. Yeah, sure. Yeah, that's the code. Basically, the main difference is that the name is defined as the private one, as the private attribute, and in Tite coupling, the name is defined as the public one. And the approach in Tite coupling is that we access the attribute name directly by just this way. We do it directly, and here we do it directly. But here we use setter and getter methods to deal with them in a correct way, to have a better setup, and to have the right explanation why something goes wrong. Right? Yeah, this is about coupling. Maybe one more thing. have another example of that and host coupling. Maybe we can do it even here, or just let's create another example. I will share the codes with you. Maybe yeah, most likely that would be or today or tomorrow. But I will share all the codes we are writing here with you, so don't worry. Alright, let's create an example of yeah, again, this is not a good approach, that coupling 2, because yeah, the class is already created, so let's don't touch it yet. Just another small example. Let's have the class Tite Coupling 2 and another class, just example class for example. Okay, I've taken this one from the internet, so let it be the same way. And class topic, for example, then has the public void understand, and has the public void a moment. Yes, void understand. Understand, and then let's print out system out print ln that coupling concept, for example, and let's create a new attribute here, topic t equals topic, right? Then let's call the method understand in this t understand. Yeah, we cannot access this one. Let's create the object here, Tite Coupling 2, an instance equals new Tite Coupling 2, and let's call the instance t and let's call the method understand. Right, not yet, sorry. Let's have public void. Let's start reading. Start reading this one. Then let's again. This t understand, right? Let's yeah. Okay, yes, let's call the method, for example, from here. Okay, doesn't really matter. Let's skip this void, we don't even need it here. Just let's show the main concept. So, as we can see, the class Tite Coupling depends on the class topic. Why? Because we have the method which is just called from this class. So they are very tightly coupled with each other. So it means that if I do any changes in a class topic, I will have I will probably most likely I'll need to do the changes inside this class. So they are coupled, and again, if I do any changes here, I'll need to do most likely changes here. And yes, if for example, if we change even the method name, for example, to any different, for example, just get it, for example. We now need to change the method here as well. So in this case, it's not the best way, because there's a Tite coupling here. And let's create another example, which will be the last example today. Basically, we'll try to fix this code to make it better, to use ghost coupling approach to fix it. Again, let's ghost coupling to this. Okay, let's just copy the same code, because we'll need to work with it. New topic. Let's just call it topic 2. Right. Okay. There is a bit. Okay, we'll start with interfaces. I don't really. Okay, there's a bit. We need to do it. Okay, I will create it this way, but maybe we'll talk about the interfaces a bit later. It's maybe just a short introduction. Topic 2, right? So maybe call topic int. Interface. Let's create a new interface. We'll talk later about the interfaces, don't worry. So maybe this example will even help you to understand the concept of okay, we need to just can use this one. Right, we have the interface, we have the void defined in the interface, the method. Again, there is no implementation, as it can happen in interface. Then what we can do, let's create. Okay, we have already the class topic 2, and let's assign the interface to it. Implements topic interface, then let's implement the method public void understand. In this case, it implements method understand, right? And then just press simple. Just put simple system out. Again, print on. Got it. Yes, and then let's create another class like topic free. Topic free, for example, right? Free, and in this case we just can write understand. Yes. And then let's use the standard, not the standard, but the base class. Yes, topic 2. No, let's just, okay, that's even more trickier for you, but let's topic interface. Okay, yeah, that may be a bit complicated for you at the moment, so don't worry, but we'll, so since you will have this code in your folder, you will be able just to check it, and after we go through the topic of casting and interfaces and all this stuff, then understand. Yes, that's the method. So what's the problem here? Oh yeah, sorry, I'm just totally confused. Public void, yeah. Again, public void, public static void main, void main again, string values. Here we need to put it here. And again, we have the interface. Then let's go understand. And in this case, these two classes are horizontally coupled, and they both are using the same interface. But okay, yeah, that's maybe not the best example to show at the moment. So, but the idea is that that's the way how we can use the coupling here and make it better. But I think we'll discuss this approach a bit later when we'll talk about the interfaces. The idea is that just these two classes, which we use for our base class, these two classes implements the same interface. So even in case basically nothing can be changed directly to these two classes without changing the interface itself. And in this case, these two classes are loosely coupled. And even in this case, we have the strict interface, which will basically control both these classes. But don't worry, that may be a bit complicated for you. We will discuss it later. This is just a simple example how to solve the coupling in this case. And okay, I think maybe we'll discuss something a little about cohesion next session. Just for now, as so if there's anyone who still hasn't hasn't created the repository in Bitbucket, please do it and share it with me. Again, if you have any issues, also contact me. I will help you. First, I've seen there are already some questions to me, so let's solve all the problems so we can move on. Again, yeah, the home task for again, remember for this Wednesday, please finish activity 3, as we already discussed for those who haven't done it. And after that, for Saturday, please till the end of Saturday, please finish activity 4 with the extra tasks of activity, extra tasks. No, actually, there's one task only for activity 4. And I think that for the third one, I think you were asked to do activity 1, 2, and 3, as I remember correctly. Then for the next one, just you're welcome to do activity 4, right? If I remember correctly. So I see Zan is typing something. Yeah, let's wait. Yeah, the answer to Zan, no. I will just I will see it once the changes are pushed. So after that I will. But yes, if you want, you can type that you have sent your homework, so I can check it. But anyway, I will see it when the changes are pushed. And I will check them together. And I mean, all the home tasks will be checked together. And yes, regarding the extra activity, yes, all the 6 sections. But okay, I think for extra activities you can do it this way, that until Wednesday, please finish activity 1 and 2, right? And till the end of the Saturday, please, you're welcome to finish activity 3 and 4. I think it should be fine, right? Okay, then thank you for joining today. Have a nice tomorrow, and let's meet on Wednesday. Thank you, and goodbye.